This will be the third part of the video series on how to solve algebraic equations. In this section of the video series, I will be going over how to represent word problems using algebraic equations. Here is an example of a problem that you might see that you have to represent using an algebraic equation. Marta has 8 colored pens. She gets 4 new colored pens every month. How many months will it be until she has 32 colored pens? So, we need to represent this problem using an algebraic equation. Our first step that we need to do is figure out what our variable will be and what it represents. So, our variable, we just pick a letter. I'll just do x. It's simple. Then we need to figure out what we are counting, what the question asks us to count. So if we look back at this question, how many months will it be until she has 32 colored pens? So you might think to yourself, okay, well, we're counting colored pens. But in this question here, do we know how many colored pens we want to have in the end? Yes, we do. We want 32 colored pens. But what do we not know? What are we counting that we don't know? Well, we're counting how many months it will be. We don't know how many that will be. So the thing that we're counting in the question that we don't know is what our variable represents. So in this case, x is the number of months. So I will use this to help me write my equation. To write my equation, I think, what does she start with? Well, at the beginning, she has 8 pens. And now, is she adding more pens or taking pens away? In this case, she's getting more pens, so she's adding pens. She's actually adding 4 every month. So if I were to do some examples here, the first month, she starts with 8, then adds 4. The second month, she starts with 8 again. She has the 4 from the first month, and now she adds 4 more. The third month, she has the 8 that she started with, the 4 from the first month, 4 from the second month. Now, in the third month, she's adding 4 more. I'm starting to notice a pattern here. Every time I'm adding 8 and some 4s, I could write it like this. 8 plus, I have 1 4, 8 plus, well, here I have 2 4s, so 4 times 2. Here I have 3 4s, so that could be 8 plus 4 times 3. These here will help me to write my expression or my algebraic equation. I need to figure out what is my pattern. Well, every time I have 8, so I have that here. Every time I'm adding, so I have that here. Every time I have a 4, so I can write that. Every time I have times, so I'll write that too. Now, every time here, nope, not the same. So, if I have a number that changes, instead of writing the number, I'll write the letter, or our variable, 4 times x. So I'm multiplying. I said x is the number of months, and that makes sense here. I'm multiplying 4 by the number of months it's been. It's been 1 month here, 2 months, 3 months. So that makes sense to put an x there. So far I have 8 plus 4 times x. Now I want to know how many months it will be until she has 32 colored pens, or until it equals 32. So here's my equation for the problem. Now I am going to use this equation to help me solve the problem. I'm going to solve this exactly the same way I've been solving all of the other equations that look like this. I'm going to rewrite it down below. 8 plus. Now, do I need this times here? If I have a number and a letter, do I have to write the times sign? No, I don't. So I can just write 4x equals 32. Okay, I'm going to do some opposites here. I have a plus, so that means I need to subtract. I have just a number over here, no x's, so I don't want to do minus 4x. If I do that here, I can't do 32 minus 4x. So in that case, I'll do minus 8 on both sides. 8 minus 8, 0, plus 4x equals 24. I don't need this plus 0, so I'll go ahead and get rid of that now. Now I have 4x equals 24. I know 4x is really 4 times x. Opposite of times, divide. So if I have times 4, I'll divide by 4. 4 divided by 4 is 1 times x equals 24 divided by 4, 6. So in the end, my answer is x equals 6 or 6 months. So now we are going to add another part to this question. So far, we answered the first question and we came up with this equation to represent it. Here's the next part of the question. Samantha has 12 colored pens. She gets 2 new colored pens every month. In how many months will Marta and Samantha have the same number of pens? So just like before, I'm going to use an x as my variable, and I'm going to keep it the same. If x was the number of months for this expression up here, x is also going to be the number of months in this equation. I'm counting the same thing. Next, I want to write an equation that represents the number of colored pens Samantha has. Well, Samantha starts off with 12, and now she's adding 2 pens every month, 2 times x. But I know I don't have to write the times. I could just do 2x. So now I have Samantha's equation, 12 plus 2x. It looks really similar to Marta's. We just have some different numbers. This is what she starts with, 12 instead of 8. And every month, instead of getting 4 pens, she gets 2. So now the question that we need to figure out is, in how many months will Marta and Samantha have the same number of pens? So if they have the same number of pens, that means they are equal. Here's the number of pens that Marta has. This is Marta. And here is the number of pens that Samantha has. We are finding now what x equals when Marta and Samantha, when their equations are equal to each other. So we are going to solve this exactly like how you solved the other equations that looked like this, the exact same way. So my first step is to do some inverse operations or some opposites. If I have plus, I'm going to be minusing. So I can subtract either the 8 or the 12. In this case, I'm going to do minus 8 because I think it's easier to do 12 minus 8 than it would be for me to do 8 minus 12. So I'll draw my line. Positive 8 minus 8, that's 0. Plus, I didn't take away any x's, so I'm left with 4x equals 12 minus 8, 4 plus 2x. This plus 0 here doesn't change anything at all. Doesn't change the value, so I can just go ahead and get rid of it. Now I'm left with 4x equals 4 plus 2x. In my last video, if you watched it, I talked all about how when we're solving equations, we need to have one thing equals one thing. In this case, I have one thing, so that's good, equals, but two things on this side. I still have two, which means I need to get rid of one of them. So if I'm adding, I need to subtract one of them, so I'm left with just one thing on the right side of the equal sign. So I'm adding, which tells me I need to subtract. So you might be thinking, well, let's subtract the 4. There's a problem though. I can't do 4x minus just a 4. If I have x's here, that means I need to take away x's. So that will not work. If that doesn't work, that tells me instead I need to subtract the 2x. Now this is something I can do. 4x's minus 2x's. I'm left with 2x's equals 4 plus 0. Once again, I don't need this 0, so I'll get rid of it. Now 2x equals 4. I know this 2 right next to the x really means 2 times x. I will do opposites now. I'm left with one thing equals one thing. So I can do some division now. Opposite of times, divide by 2, divide by 2, and I'm going to write off to the side over here because my pen won't reach under there. 2 divided by 2 equals 1 times x equals 4 divided by 2, 1. I know I don't need this times 1 here. So anything times 1 just equals itself. So in the end, I have my answer. X equals 2, or in the context of this problem, in 2 months, they will have the same number of pens. Now I have 2 problems for you to try on your own. Michael has 6 cookies. He can make 5 cookies on a pan at once. How many pans of cookies does he need to put in the oven to have 31 cookies? So there's a pan that he can put cookies on, 5 at a time. So how many times does he have to put the pan in the oven, 5 cookies at once, until he has 31 cookies? So you will pick a variable and say what it means, write an equation to represent this problem, and then figure out the solution. After that, there's a second part. George has 12 cookies. His pan can make only 3 cookies at once. How many pans do they each need to put in the oven until they have the same number of cookies? So you will once again have that variable and what it means, write an equation to represent the number of cookies George has here, write the equations when they're equal for George and Michael, and then the solution to the problem. So you can pause the video, solve on your own, then play the video again to check your answers. These are the answers that you should have. So in my case, for the variable, I picked x You might have picked another letter, but either way, you have to have that whatever variable you picked is the number of pans. If we look at the question, the thing that we're counting that we do not know is the number of pans. We know how many cookies we want, but we don't know how many pans we should have. So x is the number of pans. The equation to represent Michael's cookies is 6 plus 5x equals 31. You maybe put 6 plus 5 times x equals 31. That's fine too. I took it out because later when we get down here, I think it's easier to solve when we don't have the times in there. In the end, your solution should be 5 pans. Takes 5 pans until he has 31 cookies. Now down here for George, the variable should be the same. X is the number of pans, or if you picked another letter, it should be the same letter that you have up here. Whatever letter that is the same it's the number of pans. The equation for George should be 12 plus 3x. Once again, you might have had 12 plus 3 times x. I took it out so it's easier to solve. Making them equal, I would have 6 plus 5x equals 12 plus 3x. Then I solve, and you should get 3 pans. After both of the boys put 3 pans in the oven, they'll have the same number of cookies. So if you got any parts of these questions wrong, check your work to see where you went wrong, and maybe go back and watch my explanation on the example problem to refresh your memory on how to do any of the parts. This is now the end of this video. Hopefully you have a little bit of a better understanding of how to write algebraic equations to represent word problems.